This video shows how to create the wing of the L23 using the airfoil that we imported in the last video. Clean up the tree a little bit, and we're going to call that root airfoil, and we're also going to insert a geometric set called wing geometry. Want that outside of root airfoil. Okay, and this is going to hold a sketch on the XY plane that outlines the geometry of the wing. So in this sketch, we'll have all the edges of the wing, essentially just lines located relative to each other in such a way that we can dimension them, and then when we make translations and scalings of the original airfoil sketch, we can reference these dimensions. That way, later if we want to change the shape of the wing, we can come back into this sketch and just change the dimensions, and all the 3D geometry will be updated automatically. So here, the H axis is parallel to the X, V is parallel to the Y, so span will go up. And we're working on the tip right here. I have all the dimensions that I just took from measuring and reading things off of 3-view drawings of the L23. Here we're going to put a point at the 25% chord with the tip as well as the root, so that we can position the tip and the root according to the sweep of the 25% chord, which is one of the parameters that I have that I'm drawing this off of. And to make things easier, we're going to name all of our dimensions so that in the tree it'll be easier to pick out later. And so the 25% chord, we just set that point coincident to the line and 25% of the total length from the end point. We'll do the same for the root chord. And 25% root chord, 25% tip chord. Now we'll add a line coincident to each of those points. This is our 25% sweep, or I'm sorry, this is just our, so this is 13 degrees. We'll call that sweep. Sweep. The 25% chord to be more specific. And that's enough to go off of to start. So we'll define the root airfoil in our tree, and we're going to scale our initial spline based on a point at the leading edge. So we'll go insert point, tangent to curve to the Z direction, and so that'll give us a point on the leading edge. Then we're going to scale it just one. So this is exactly the same as the old airfoil, but this is a good practice in case you end up changing the root chord later. You don't have to start over from scratch. You can just scale this. If you go about creating the rest of the geometry based off of the initial, you have no way to scale the initial. So to scale the initial, you have to delete everything you did after. So this is just a good safety measure to incorporate. Now we're going to translate this in the Y direction, and with a distance equal to half wingspan, which is a dimension we created in our sketch earlier. We'll It lists tip airfoil. Actually, let's call this translation of the half wing span. That's what the translate is, the span. And to get the offset in the x direction, we need to create a reference dimension in our sketch from the leading edge of the tip and the root. So the tip leading edge offset, we'll call that. And we're also going to, while we're in the sketch, create the dihedral angle measurement for and this is obviously would be in the different plane of view, the ZY plane, but we'll just draw it in the sketch for convenience. And we can set the span equal to the other span, coincident to that H axis there, and set the dihedral as the angle, which will give us the tip offset, which is what we'll use to translate the tip airfoil in the Z direction later. So first we'll translate the tip, or we'll scale the tip to get the right taper ratio. Again, put a point at the leading edge to scale it in reference to. And that equals tip chord, press the formula button, divided by root chord. Okay. Okay. There we have it. We'll call this scaling taper ratio. Now we'll translate in the x direction according to leading edge offset. There we go. And in the z direction according to dihedral offset. Hide all the other junk. And now we're going to create a line connecting the leading edges, or the trailing edges. Leading edges of the two airfoils, which we will use as a guide for when we do a multi-section surface, which is going to be the right wing skin. And we'll move all of our components, change the geometrical set. And that's the leading edge contour. And we will also do a trailing edge contour. Set that as a length of 0 from along the curve. That'll get you to the starting point, which is the back edge. Okay. And now a multi-section surface. Get that out of there. The guides go in the second box. Your sections go in the first box. There we have the wing skin. To create the left side, which you don't necessarily have to do now. You might want to build a whole half model of the plane, but we'll just show how to do it. Reflect it across the ZX plane. And we'll hide all of the sketches that we had. And get a nice isometric view.